Some salts are soluble, but many are insoluble or slightly soluble in water. So the solubility, we use the S symbol, is the quantity that dissolves to form a saturated solution. It is usually expressed as gram per liter, the solubility, which is the grams of solid dissolved in 1 liter of a saturated solution. And also we have the molar solubility in mole per liter, which is the moles of solid dissolved in 1 liter of a saturated solution. The solubility product constant, the Ksp, is the equilibrium constant for the equilibrium between an ionic solid and its saturated solution. Just as with acid-base equilibria, we can describe the concentration of ions in equilibrium with an ionic solid using an equilibrium constant expression. So the equilibrium constant is the ratio of the concentration of the product of a reaction divided by the concentration of the reactants once the reaction has reached equilibrium. Consider this reaction, AgCl solid in equilibrium with Ag plus ion and Cl minus ion. Because of AgCl is a solid, its concentration before and after the reaction is the same, so it is constant. So the Ksp expression is equals to the concentration of Ag plus times with concentration of Cl minus. For substance in which the ions are not in 1-to-1 ratio, the stoichiometric coefficient of the reaction become the exponents of the ions in the solubility product expression. For example, PbCl2 solid in equilibrium with Pb2 plus ion plus 2 moles of Cl minus ion. So the Ksp expression is equals to concentration of Pb2 plus times with concentration of Cl minus to the power of 2. So this is the coefficient of the Cl minus. Like other equilibrium constant, the Ksp depends only on the temperature, not on the individual ion concentration. So the higher the temperature, the higher the Ksp, the greater the solubility. Given the value of Ksp of MgCO3 and PbSO4 at 25 degrees Celsius, as we look at here, the Ksp of MgCO3 is higher than Ksp of PbSO4. So in this case, MgCO3 is more soluble compared to PbSO4.